Welcome back. In this episode, we are going to learn about the concept of chat memory, which is a very important concept while building a AI-powered application. So, basically, LLMs are stateless, which means they don't remember or carry on the previous conversational context. So, if you share some information about yourself in one interaction, and then immediately if you ask for the same information, they don't remember it by default. But usually while building any chatbot kind of applications, you do expect the AI to retain that context and provide the meaningful responses for the further questions. So this is where chat memory concept comes in, where this is a mechanism where we can provide that extra context from the previous conversation we are having, and then LLMs can take that context into account and then provide you the proper response. So let's see how we can implement this concept in our Spring AI application. And also Spring AI out of the box provides some chat memory repositories where all the chat history retains. So let's see how we can implement chat memory in our application. I have created a new module called chat memory, and again this is same functionality that you have already seen many times. So in this module we are using ollama, and in application properties we have configured the base URL and which model we want to interact with and all the parameters. And we have one chat controller, and again, we have one API endpoint where we are passing some input prompt, and we are calling LLM by passing the same prompt, whatever we are passing. And then once we get the response, we are returning that as the output, which contains content. So plain straightforward. And also, we have already talked about this advisor, where we are setting this as a default advisor, simple logger advisor as a default advisor, so that every interaction we have with this chat client instance, it is going to log the request, and once we get the response, it's going to log the response. So we can see all the details about what is being sent to LLM and what info we get from the LLMs also. So very helpful for debugging or understanding what's going on behind the scenes. So now that we have all this configuration, in addition to that, I have added one more thing to this application, to this module. I have added this timeleaf support, and also added this index.html. So basically this is nothing but a simple chart UI where user can enter some prompt and then submit. Once the user submits it, we are making a call to this API chart endpoint, and then we are passing whatever the user input. And once we get the response, we are adding a message to this chart UI. So let's start the application, and let's interact with the LLM from UI. So here, this is the UI we have. Now first, let me tell hi, my name is Siva. So here, this is my first message, and then LLM respond with hello Siva, how can I help you today? And then let me ask, what is my name? I'm not sure what your name is. Could you let me know? Here you can see each conversation, like here, this is one conversation. Hi, my name is Siva. I send it to LLM, and this is the response I got. And then in the next conversation, I asked what is my name, and LLM respond with I am not sure, because each of this conversation is completely independent. They do not have any conversation history maintained. So it is not able to remember the previous conversation, and it cannot answer what my name is. So this is where chat memory concept comes in, and we usually want our chatbots to remember certain, at least to some extent, remember the previous conversation history so that it can respond in a meaningful manner. So something like this. If I say immediately I gave some information and then I ask the same information, it is not able to tell the same details. But we do expect chatbots to remember that conversation, right? So let's implement that conversational history using chat memory concept. Now, let me go back to the chat controller here. And for chat memory, Spring AI already auto-configured a chat memory implementation using the defaults. So we can add this chat memory. Once we have this, and we can add it as a default advisor so that for all the conversation that I'm having with LLM by using this chat client instance, it is going to automatically add this advisor. Okay, so here once we have this chat memory instance, we are adding this message chat memory advisor dot builder and take this chat memory instance and build. So we are adding this also as another advisor in this chain as a default advisor. So this memory chart message chart memory advisor, what it will do, every time when we are having a conversation with LLM, in addition to the current message, it is going to take the last n number of messages and also include them so that it will have this previous conversation history, and then it will take a look at all of those messages and be able to respond in a meaningful manner. And by default, it is going to have 20 messages in a window. And if you are having more conversations, it is going to delete the previous conversations. So that is the default behavior. And currently the chat memory is an interface, and it has this message chat window memory implementation. This is what is already auto configured. And as you can see here, we have max messages as 20. So this is the default one. If you want something else, you can also configure your own chat memory implementation. In addition to that, here if you take a look at chat memory repository, so again this is an interface with few methods, and we have an in-memory chat memory repository. So all the messages are stored in this concurrent hash map. Okay, so these are the background things that are auto-configured by Spring AI. Now, once we have configured, injected this chat memory and added this message chat memory advisor as a default advisor, now we are going to have the same conversation, but this time let us see the difference. So let me restart. And let's start with, hi, my name is Siva. What is my name? Your name is Siva. So now it is able to remember the previous conversation and then respond with the proper answer. But how it is able to remember the previous conversation? Now let us take a look at the request and response. So in the last response, so this is the request we are sending. So now if I take this complete request and let me paste it in a different window. So here, okay. So this is the request, the second request. That means when I sent what is my name, the second request, it not only sent the final what is my name user message, but also added the previous interactions with the LLMs. So here previously I have asked, I interacted with saying, hi, my name is Siva. And then LLM responded with, nice to meet you. How can I help you today? And then now I am asking this new question. So previous conversations are added as part of the request itself, so that LLM is taking all this context into its consideration and then responded because it has this information. It is able to say what my name is. So all this is automatically happening because of the advisor. So we have configured the message chat memory advisor. So right now we only have 2 or 3 messages only, but it is going to, by default, as we have seen, it is going to retain the 20 messages in a window. So that is going to automatically take care of maintaining the context. But again, let's say you said something, you pass some information about yourself or something else, and then you have other conversation like 25 conversations. And then if you ask the same information, it may not remember because that has been removed from the context. like it can only hold 20 by default, right? So based on the kind of application you are building, you need to adjust the parameter, how long you want LLM to remember the previous conversations and all that. Okay, so that is how you can simply configure the message chat memory advisor, and it is going to take care of passing the previous conversations and have the context. So this is how you can configure. But so far, this is using in-memory advisor, which means if you stop the application, all that context is gone. It doesn't remember anything. All the info is there in memory. And as soon as you stop the application, all that context is gone. But if you, of course, if you are building a production grade application, you would like to keep that interactions probably in a persistent medium. So this is where there are other options available in addition to in-memory chart. So we have this, right, chart memory repository, and currently it is using in-memory chart memory repository. But we can store the messages in JDBC, any database, or you can also use Cassandra or something like that. So let's see how we can configure a database to store all this chart history. Okay. I have added this Springboot Docker Compose support. I would like to store the messages in PostgreSQL, and I want to use Docker Compose support for interacting with the PostgreSQL database. So I have added this dependency and also created in the project module root. I have created this compose file and configured the PostgreSQL database. And then if I take a look at this, I have added this PostgreSQL JDBC driver as well. And I have added this Spring AI starter model chart memory repository JDBC. So I am going to use JDBC support to store the chart history in the database. And in this case, we are going to interact with PostgreSQL. So this is the configuration. In addition to that, I have also configured this property, Spring AI chart memory repository JDBC initialize schema always by default. It depends on the database you are using. If you are using in-memory H2 database, it will automatically create those tables. Otherwise, you need to either explicitly create those tables. But here I'm using always option. That means it is going to create the table if it is not already exist. So the table creation script is already comes a part of this dependency. So you don't need to write that by yourself. So here I just enable that table creation. So with this configuration, if I restart the application, it is going to spin up a Docker container, and let's see here. I'm going to see this Spring AI chart memory table. There is a table created. Right now, there is no data in it. But if I go to here, let's start with, hi, my name is Siva. So here I sent a message, and if you come here, and see, by default the conversation ID, by default it uses default and it stores this information, and this is of type user message. And then once we got the response here, that information is also stored again. This time it is coming from the assistant, so the type is assistant. So like that, all the conversation that we are having with, let's say I'm asking what is my name. Again, this is going to store in this table. So this information will be captured in the persistence medium, like in our case PostgreSQL. You can also use different types of databases, but in this case we have configured our PostgreSQL to store all this information. So this is as simple as it, but all is good. But right now we are assuming that only one person is interacting. But how we can make different people maintain different conversation. For example, if it is a web application and we build some chatbot kind of application, multiple users parallelly can interact with the LLM. But how do we differentiate which message belongs to which conversation? Right now, we do not provide any specific conversation ID support. So all of the messages are tied with default conversation ID. Of course, this is not going to work if you are building a multi-user based application, right? So now let us see how we can implement these conversations support so that multiple users can interact with the LLM and still keep their conversations isolated. So let's see how we can implement that. So here I have updated the logic in this API endpoint where in addition to the input which contains the prompt, I am also binding a cookie value with this name. So conversation ID required false, it may not exist. And what I'm doing, if it is null, I am generating a random UU ID as a conversation ID. And then I'm making a call to LLM, but also I'm adding this advisors. Here I'm specifying this conversation ID is nothing but this one. So if we have already a conversation established and it is going to send it as a cookie, we are going to take that value and then make this new interaction also part of the same conversation. Otherwise, if it is null, which means we are starting a new conversation. In that case, we are creating a brand new UUID and we are setting the conversation ID to that new conversation ID. And then again, we are getting the response, and while sending the response to client, we are also creating a cookie with the same conversation ID and set it as to max path and all that. And while rendering the returning the response, we are also using this HTTP headers set cookie to set this cookie value and sending the response. So basically with this one, let's go to our UI, and here let's open this. In the application tab under cookies, let's say we don't have, let's clear it. Okay, so here we don't have any cookies right now. So I'm going to start the conversation first. Hi, my name is Siva. So when I started, it is, let's refresh. Once we get the response, it will set the conversation ID. So here you can see the cookie xconv ID, and this is generated. The last is F73. Now, if we go to our database and check, so we have this F73. These two are from this conversation. Now let's say what is most popular Java testing library? Let's ask something. Okay, so I asked some question and it should be part of the same conversation. So here it already stored with the same conversation ID. But now if let's say I started another browser, here I started Firefox browser, and imagine I'm a different client. Now let me ask what is the popular ORM library in Java. So here, this is my first conversation. So it is supposed to start a new conversation. So here it is a different one. Here 723, and if you take a look at the cookies and all, you can see this belongs to the conversation from Firefox, and all these conversations are from Chrome. So this is how you can keep track of conversations per user basis for different conversations. So you can also implement your own chat memory implementation. If you want to capture more information instead of using the default one, you can also implement your own thing. So this is how you can implement a chatbot that retains the previous conversations and then provide meaningful information. So I hope you got the understanding of why we need chart memory concept and how to implement that by using memory message chart memory advisor. So this is how you can implement a chart memory concept. And as we have seen, we can also support different chart conversations with a different unique ID. So I hope this helps, and thanks for watching. Bye bye.